Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In the previous lecture, we started with the new subject, which is probability. And in today's lecture, we'll move forward with probability. In today's lecture, we'll discuss three kinds of probability. First one is subjective probability. The second one is geometric probability. And the third one is inverse rule of probability. First one is subjective, means where the probability we discuss in everyday life talking to each other, which is not done mathematically. That is subjective probability. That is whether today will rain or not. With how much surety do you say that today will rain? Whether I will pass this interview or not. With how much surety can you say that I can pass this interview? Whether my friend will come to attend this wedding or not. All those things that we discuss in day-to-day lives with our friends and family members or colleagues, that is known as subjective probability, which is not done on paper and which has no proof mathematically. Now, geometric probability is nothing but probability that a region, that something covers a region upon total region of that thing. If I say that measure of specified part of the region, geometric probability is measure of specified part of region upon total measure of region. If we talk about a circle, suppose, and we have to estimate the probability of this part from the circle, then suppose this part is P and this part is Q. So the geometric probability would be P upon P plus Q whole part. This is known as geometric probability. It can ask you what do you mean by geometric probability. Now the third kind of probability is inverse rule of probability. You must be knowing conditional probability. Probability of A given B, which states that probability of occurrence of an event A when B has already occurred. This is known as conditional probability. Inverse rule of probability is nothing but our Bayes theorem. What does Bayes theorem say? Bayes theorem is exactly opposite to that of our conditional probability. Bayes theorem will say that probability of occurrence of an event I when A has already occurred just before this, then it is nothing but probability of A into probability of A given EI upon probability of A. Here it will be EI, where probability of A is nothing but summation of I goes from 1 to n probability of EI into probability of A given EI. This is our Bayes theorem. I hope that you all know what our Bayes theorem, where all I goes from 1 to n. Bayes theorem is simple. You just have to need to revise your concepts. This forms the basics of our probability, and this is very important topic. I hope that you all know what Bayes theorem is and how is it applied. We'll do some of the PYQs and normal questions as well today to solve how the how do they give us questions in the examination and how do we solve them. Let us see some of the questions. Here they have given us a die is rolled. I hope that you've seen the question. Let me take it aside. This is the question of our 2020 examination. A die is loaded in such a way that each odd number is twice as likely to occur as each even number. Suppose the probability of an odd number and probability of an even number. Let us say that probability of an even number is p. Then probability of odd number is twice as that of even, so it will be 2p. Let a be the event that the number of rolled is greater than 3. So a event means that the number that comes on the dice is greater than 3. There are three numbers, 4, 5 and 6 that can occur. And the probability of b, that b is the event that the number rolled is a perfect square. There are two possible cases, 1 and 4 to be a perfect square. A dice shows six numbers, 1, 2, 3, 4, 5 and 6. So out of them, the ones which are greater than 3 has been done, 4, 5 and 6, and one which are squares, which are 1 and 4. So that's what I have written here if you don't know the concept. I hope that you all know the concept, which is very basic. Now they have given us two results and said us to which one is correct or not. If we say the first result, before that let us draw this probability chart. Here we have been given x and here we have been given probability of occurrence of x. The numbers are 1, 2, 3, 4, 5 and 6. Probability of odd number is 2p. So I will write 2p here on all odd numbers. And probability of all even number is p. So I will write p on all even numbers. Now we know that the summation of all the probability, one of the axiom, the summation of all the probability should be equal to 1. If we sum them all, they will be 9p, that should be equal to 1. So from here we get the value of p as 1 upon 9. Okay, this, let us take this. Now first is probability of occurrence of b. B is occurrence of 1 and 4. So occurrence of 1, probability of occurrence of 1 is 2p and the probability of occurrence of 4 is p upon total occurrence is 9p. So it will be 3p upon 9p, which is 1 upon 3. In the question they have given probability of b is 1 upon 3, that 1 is correct. Then this can be correct and this can be correct. These two get cancelled. Next option would be our probability of b given a. If we say the conditional probability of b given a is given, then we say that probability of b intersection a upon probability of a. Now probability of b intersection a means the common terms between them. So b intersection a is nothing but equal to 4. So the probability of occurrence of 4 will be, probability of b intersection a will be the probability of 4 is p and the total probability is 9p. So it will be 1 upon 9. And the probability of a will be 1, 1, 2, 4, 5 and 6. So 4, 5 and 6 will be p, 2p and p will be p plus 2p plus p will be 4p upon 9p, which is equals to 4 upon 9. If we put the values of probability here, 1 upon 9 upon 4 upon 9, then it comes out to be 1 upon 4. And in the question they have given us 1 upon 2. So this is not equal to 1 upon 2 and hence this statement is wrong. So our only one option is correct, which is 1. That probability of B is 1 by 3. This was a question of conditional probability. How to solve them in examination, I've told you. This is the most extreme question that they can ask. All the other questions that they have asked are much easier than this one. You can attempt those, and if you face any doubt, then you can ask us. Moving on to the next topic, which is Bayes theorem. One such question, we'll take it from very low level to a higher level. So they have provided us with this table where we have been given 50 men. So let us we have been given 50 men. We have been given a data of men and women who are blind. So let us say that E is the event of blind person. Then probability that a blind person is a man is given by 50 upon 1000, and probability that blind person is a woman is given as 25 upon 1000. Now probability given is blind. Let us take that from the very starting. Let the event E be a blind person, and probability that a male is selected or probability that a female is selected is half. Both of them are half. Now probability that a male is blind, given that a male is selected and it is blind, it has the probability as 50 upon 10,000, which have been given in the question. 50 out of 10,000 are blind. And probability that a woman is selected and is blind, we can say the event is E, then it is 25 upon 10,000. We have taken this. Now we have to put the Bayes theorem, because they have asked you to calculate probability that a blind person is selected. Tell us whether what are the chances that it is a male. So we'll reverse it. This is known as the reverse rule of probability. So we'll reverse it, and this should be equal to of probability of M into probability of M given E upon probability of M into probability of M given E plus probability of W into probability of W given E. We have to find whether it is a man, so we'll keep it on numerator, and the total we'll keep it in denominator. Writing the values that we obtain from here, probability that it is a man is 1 by 2, and probability that it is M given E, that the man is blind, is 50 upon 10,000. Upon the same one will come here, 1 upon 2 into 50 upon 10,000 plus probability that it is a woman will also be half, and probability that the woman is blind is 25 upon 10,000. And 10,000 and 2 will get cancelled from numerator and denominator. We'll be getting 50 upon 75, which when divided by 25 each will give us 2 upon 3, which is our option number C. This is how we attempt a base question in the examination. I hope that it is clear. Now moving on to another question. Here it is an urn problem. Urn means pots. So we have been given 3 urns: urn 1, urn 2, and urn 3. Urn 1 contains 5 white balls and 8 black balls. Urn 2 contains 6 white balls and 7 black balls, and urn 3 contains 11 white balls. Then a urn is chosen at random. Probability of choosing any urn, probability of choosing first urn, probability of choosing second urn, and probability of choosing third urn should be all same. So this is 1 by 3, and it turns out to be white. Then probability that urn 1 is chosen when white ball is there, it will be from urn 1 how many white balls are there? 5, and total number of white balls are total number of balls in the urn are 13. Then probability that urn 2 is chosen and white ball was there will be 6 upon 13, and probability that earn third is chosen and white ball is there is 1, because earn 3 contains only white ball, so no matter what ball we select, we'll only get the answer as 1. Now they have asked you the probability that the ball came from the third urn is. Now we know that the ball is white, but it came from third urn. Inverse rule of probability. So it will be probability of urn 3 into probability of urn 3 into given that it is a white ball upon total probability. Probability of earn 3 into probability of earn 3 given white ball plus probability of earn 1 into probability of earn 1 given white ball plus probability of earn 2 into probability of earn 2 given white ball. Now just keeping the parts here, probability that white ball is chosen from earn 3 is 1 upon 3 into on 3 is 1 upon 1 upon 3 into 1 plus 1 upon 3 into 5 by 13 plus 1 upon 3 into 6 by 13, which is equals to 1 upon 3 gets cancelled from numerator and denominator. We'll be getting 1 upon 1 plus 5 by 13 plus 6 by 13. On solving it, we'll be getting 1 upon 24 upon 13, which is nothing but 13 upon 24, which is our option number D. That's how you solve the question of Bayes theorem. Now moving on to some PYQs of Bayes theorem. PYQs are also simple if you understand the concept. Here they have provided us with 3 companies producing light bulbs. Then let us and some of are defective. Let the event be that there is defective bulb. Okay. Then probability that A factory is chosen is 40%, which will be 40 by 100. Probability that factory B produces the bulb is 35%, and probability that factory C produces the bulb is 25%. Now, probability that uh, factory A is chosen and from that the bulb is defective. One bulb from factory A is chosen and that comes defective is given by 2% are defective, which is 2 upon 100. Then probability that from factory B we choose a bulb and it comes out to be defective, it is 4%. And probability that from C factory we chose a bulb and it comes out to be defective, it is 3%. Now they have asked us the probability that it was from a factory. That if a defective bulb is found among the total output, then what is the probability that it was from factory A? So they are asking us probability that we take out a defective bulb, but it was from factory A. Inverse probability theorem, which is Bayes theorem. So it will be nothing but probability of A given E into probability of A upon total probability, which is probability of A given E into probability of A plus probability of A B given E into probability of B plus probability of C given E into probability of C. If we take that here, probability of E given A, it will be nothing but, I'm just putting the values, which is 40 upon 100 into 2 upon 100 upon 40 upon 100 into 2 upon 100 plus 35 upon 100 into 4 upon 100 plus 25 upon 100 into 3 upon 100. Now all these denominator will get cancelled from the numerator and we'll be getting as 80 upon 80 plus 140 plus 75, which will be equal to 80 upon 155 plus 295. When we cut it down by 5, we'll be getting our answer as 0.27, which is 19 upon 59. 18 upon 59, sorry. 18 upon 59, which is 0.27. Which is our option number C. You can recheck the answer while solving it. I've just solved it. Now moving on to another question, which is the last top one for today, and it is also a PYQ from ISS examination 2019. Now this is a bit trickier one. The language is trickier, but the formula is same. They have said that 5% of persons suffering from a certain disease are selected to undergo a new treatment that is believed to increase the recovery rate from 30% to 50%. So event is getting treated. Before treatment, if there are two people, one is getting treated, one is not getting treated, so the chances of recovery of not getting treated is 30%, and the chances of recovery of the one who's getting the treatment is 50%. So the probability that the treatment that a person get treated, the probability that the number of person getting treated is 5% only, and rest others are, we know that the person are not getting treated. I'm writing NT is 95 by 100. Now the chances of recovery, here it is not treated, but it should be recovering, getting recovered. Okay. Now the probability that someone got recovered, treated, and got recovered, so it will be 30%. When the treatment is there, it will be 50%. And the probability that the person was not treated but got recovered is 30%. They have given in the question. Just the language is difficult. There the question is same only. And they have asked you that we have took out the one person who has recovered. That means E is there, and tell us whether the probability that it has recovered from the treatment. Here they have tell. What is the probability that the patient recovered, received the new treatment? So it will be nothing but probability of T into probability of T given E upon probability of T into probability of T given E plus probability of NT into probability of NT given E. If we if we put the values here, we'll be getting as probability of T is 5 by 100 and T given E is 50 by 100. The same will come here, 5 by 100 into 50 by 100 plus the one not treated probability will be 95 by 100 into 30 by 100. So the denominator will get cancelled. 100 also we can get cancelled. 15 also we can cancel from here. It will be 19. So it will be equal to 5 upon, here it will be 5 plus 19 into 3, 57, which will be 5 upon 62, which will come out almost equal to 0.08, which is our option number B. So this is how we solve Bayes theorem, and I hope that the whole of the concept has been revised with all of you. And if you are facing any doubt, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.
Startup Academy presents Lakshya 2027, an exclusive batch designed only for serious ISS aspirants.